Hello, everyone. Welcome to the mini lecture on precision measurement technology. Today, we will learn a very practical skill, the establishment of the coordinate system for workpieces with one surface and two pins. This skill is particularly important in the processing of box-type parts, as it directly affects the precision of the parts and the efficiency of the processing. In mechanical processing, establishing the coordinate system is a crucial step to ensure the machining accuracy of the workpiece, especially for box-type parts with one surface and two pin positioning. Correctly establishing the coordinate system can significantly improve both processing efficiency and product quality. In this lesson, we will cover the following topics. Through today's lesson, we hope you will understand the principle of one surface and two pins positioning, be able to identify the reference surfaces and reference holes on the workpiece, and master the method of establishing the coordinate system for such workpieces in the measurement software. You should also be able to independently complete the initial establishment of the coordinate system. Before we start, I would like to ask, has anyone here ever worked with the one surface and two pins positioning method? Has anyone tried to establish a coordinate system in measurement software based on this method? Next, I would like to invite a few students to share the issues they have encountered. One student mentioned that although she had some prior knowledge of the one surface and two pins positioning method, she faced difficulties when trying to establish the coordinate system in the measurement software. The problem is crucial for the accuracy of the coordinate system. She has been working hard to find a solution to this issue. Another student shared his experience of establishing the coordinate system in the measurement software. He mentioned that he faced a significant challenge while measuring the reference hole. However, after repeatedly adjusting parameters such as the probe angle and approach/retreat distance, he was finally able to establish an accurate coordinate system. Now, to provide a more intuitive understanding of the process of establishing a one surface and two pins coordinate system, we will watch a practical demonstration video. Next, we will import the 3D model. Click on File, select Import, then choose IGES format. Select the corresponding file from the desktop, and click OK. Based on the actual placement of the workpiece, we need to adjust the orientation of the part. Click on the Operation Graphic Display window, click Transform, and rotate the part 180 degrees around the Z-axis. Coordinate System Establishment. The one surface and two pins positioning method is the most commonly used positioning method when machining box-type parts. As shown in the diagram, the combination of a flat surface, cylindrical pin, and diamond pin is commonly used to restrict the 6 degrees of freedom of the workpiece. One surface. This surface is typically the design assembly reference plane for the workpiece. The degrees of freedom restricted by this surface are the Z-axis translational freedom and the X and Y rotational freedoms. When establishing the coordinate system, this surface is also the primary correction plane. This plane is typically used to correct one axial direction, and the 0 point of this direction is set on the surface. The two pins, a cylindrical pin and a diamond pin, are used in combination with two reference holes on the end face. The degrees of freedom restricted by these pins are the X-axis translation, Y-axis translation, and Z-axis rotation. In the coordinate system setup, the line connecting the centers of the two pins determines the second axial direction. The reference hole that mates with the cylindrical pin is used to define the circular point for the other two axes of the coordinate system. In this case, the design reference of the box body is exactly a plane and two holes. Therefore, based on the principle of reference coincidence, these three references can be used to establish the coordinate system. First, in manual mode, measure the main correction plane, which is reference plane A. Switch the probe to A90B180, but here it should be A90B0. Then, in program mode, use the side head to collect 4 points on this plane. The points should be distributed as widely as possible. press the N key to stop point collection. In the software, the measurement command for plane A is obtained, and it is renamed to PLNA. Next, insert a new coordinate system A1. Select the reference plane, align it with the negative y direction, select the plane again, check the y-axis, and set the y-axis to 0. Click OK. Then, measure the second reference circle B and the third reference circle C. Set the working plane to negative y. Similarly, measure in program mode, and rename them CIRB and CIRC. Insert a new coordinate system A2. Select reference circle B and reference circle C in sequence. Rotate around the previously aligned negative y direction to the positive z direction. Click Rotate. Then select reference circle B. Check the x and z axes, set the x and z axis to 0, and click OK. As shown in the diagram, the coordinate system's origin is established at the center of reference circle B. Now, press Ctrl+Q to execute the program. Follow the prompt instructions and use the manual control to touch the three features, reference A, B, and C on the workpiece. After the initial coordinate system is established, place the cursor at the end of the program in the edit window. The correct coordinate system's origin and axis should be as shown in the diagram. Now, I invite everyone to follow the demonstration and set up the coordinate system for a one-plane 2-pin workpiece in the measurement software. After the practical exercise, please share any issues you encountered and the solutions you found on the platform after class. We can discuss and improve together. In this lesson, we learned the method of establishing a one-plane 2-pin coordinate system for workpieces, including importing the CAD model, adjusting the workpiece's orientation, measuring reference planes and reference holes, and the specific steps to establish the new coordinate system. Special emphasis was placed on the importance of the reference coincidence principle in establishing coordinate systems, and the impact of correctly setting up the coordinate system on machining accuracy. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This lesson ends here. See you in the next class.